Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 24-3 worksheet. Okay, first one, log base 3 of 10p equals 4. When you have it in this form here, we can just turn it from log form into exponential form. And I just remember that the base always moves over to the other side and pushes this up and turns it into the power. So we get 10p equals, 3 to the fourth power. So 10p equals 3 to the fourth. 3 times 3 is 9, times 3 is 27, times another 3 is 81. Divide both sides by 10, and we get that p equals 8.1. Okay? This one here, number 3, we'll do the same thing. 7 to the third equals k minus 7. Right? K minus 7 equals 7 to the third is 343. That's supposed to be a 3. There we go. So we add 7 to both sides, and we get that k equals 350. Okay? For number 5, first thing we got to do is get rid of this negative 8. So we really got to add this 8 to both sides first, and then we can turn it into exponential form. Because look, we have two different terms on one side. We want to keep it to just the one with the log. So that goes away, and we have log base 3 of v minus 3 equals negative 5 and 8 gives us 3. So this 3 comes over. We get v minus 3 equals 3 cubed, which is 27. Add 3 to both sides, and we get that v equals 30. Okay? Now, officially, we need to plug these in to double check to make sure that they all work. We just can't take the log of a negative number, but 350 minus 7 is fine. That's positive. 30 minus 3 is fine. 8.1 times 10 is fine. So those are all good. But later on, it's going to cause us some troubles, but we'll take a look at that when that happens. This one here, we've got one big term over here. We want to get rid of that 3, so we can divide both sides by 3, and we get log base 4 of p plus 8 equals 2. So now we turn it into exponential form. We get p plus 8 equals 4 squared. So p plus 8 equals 16. We subtract 8 from both sides, and we get that p equals 8. 8 plus 8 gives us positive, so we're good. Okay, on number 9, both sides have log base 14. So since they're both log base 14 and there's no other extra terms with it, we can simply just get rid of the log base 14s and solve for what we have left. Negative 2v minus 5 equals negative 4v minus 1. So I'm going to add 4v to both sides so that I get my positive v here. So we get 2v minus 5 equals negative 1. Add 5 to both sides. 2v equals 4. Divide both sides by 2, and we get that v equals 2. Okay, now here's a problem, because if we plug this 2 back in, negative 2 times 2 is negative 4. And then negative 5 gives us negative 9. Okay, so really it's saying log base 14 of negative 9. So if we were to do that, we would do, if you do log of negative 9, it gives you an error. You can't do the log of a negative number. Okay, and then really here is why you can't take the log of a negative number. If we have, let's change colors here just so you can understand what's going on here. So if we have, say, log of negative 9, what that really means, that's log base 10 of negative 9 equals x. Right? So if we turn this into exponential form, that says 10 to what power gives us negative 9. There's no way to take a positive number to some power and end up getting a negative number. It just, you can't do it, so that cannot happen. That's why this log of negative 9 won't happen. So this v equals 2 does not actually work. So this is actually, then would be no solution. Okay? All right, 11. Similar to number 9, they both have log base 14s on both sides, so we get rid of those and we get 6 minus k equals negative 3k. Let's add a k to both sides. We get 6 equals negative 2k. Divide both sides by negative 2 and we get k equals negative 3. Okay, now if you plug negative 3 and 6 minus negative 3 gives us positive 9, we can take the log of a positive number, that's no problem. And then negative 3 times negative 3 also gives us positive 9, so this actually is just fine. That will actually work, k equals negative 3. If we were actually to have gotten a positive number, that wouldn't work over here because negative 3 times a positive number would end up giving us a negative number, and you can't do that. So this actually had to be a negative number. All right, moving on to 13. Now this is a little different because both logs are on the same side and then it equals some constant on the other side. So what we want to do here is start using these formulas to combine our two logarithms together. So we have subtraction here. So subtraction means that it's going to be, we can actually turn this into, combine these two into division. So this is going to be log base 9, x plus 2. Positive part goes on the top and the subtraction part, x, goes on the bottom. And these two logs combine together to make that. And then that equals 2. So then now we can turn it into exponential form where we get x plus 2 over x equals 9 squared. 9 squared we know is 81. So we got x plus 2 over x equals 81. Now whenever we get a fraction equals some number, I usually like to just turn it into a fraction equals another fraction, and then I can do cross products, right? So that means 81 times x is going to equal, oops, I kind of messed up that circle there. It's going to equal 1 times x plus 2. So 81 times x is 81x. 1 times, distribute the 1 through, and we get x plus 2 back. I'm going to subtract x from both sides. And we get 2 equals 80x. Divide both sides by 80. And we get that x equals 1 over 40. Okay. 1 over 40 plus 2 is positive, and 1 over 40 is still positive, so they both work, so this answer is okay. All right. Last one. 15 log base 2 of x minus log base 2 of x minus 4 equals 1. So same idea. The subtraction means we're going to divide. So we take this as log base 2. The positive one's on the top. The one that we're subtracting, x minus 4, goes on the bottom. And that's going to equal 1. So now that turns into x over x minus 4 equals 2 to the first power, right? Which is just 2. So we'll put that over 1, and then we'll do cross products again. So that's 2 times x minus 4 equals 1 times x. Distribute this 2 through to both of those, and we get 2x minus 8 equals x. And we've only got a constant on the left side, and then x is on both sides, so I'm going to subtract my 2x from both sides. Negative 8 equals x minus 2x is negative x, so that means x has to equal positive 8. Positive 8 works fine there. 8 minus 4 is still positive, so they both work, so that one works out fine as well. Okay? All right, that's all we have for the 24-3 worksheet. If you have any further questions, please feel free to ask. Thanks.